Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The rate of acid-catalyzed dehydration depends on the stability of the carbocation intermediate formed upon protonation and loss of water. More stable carbocations form faster and thus dehydrate more readily. Moving on to the next step. I. The alcohol is on an exocyclic CH2 primary carbon attached to the sp3 carbon that is allylic to the endocyclic double bond and benzylic to the aromatic ring. Upon protonation and ionization, the primary carbocation can rearrange, or, more importantly, the OH is actually on a carbon that upon loss of water gives a carbocation stabilized by both allylic, from the ring double bond, and benzylic, from the aromatic ring, delocalization simultaneously. This is a primary alcohol, but the resulting carbocation is doubly stabilized. Allylic plus benzylic conjugation with the aromatic pi system. This gives very high stabilization. 2. The alcohol is secondary and located directly on the ring carbon that is both benzylic, adjacent to the aromatic ring, and allylic, adjacent to the double bond in the ring. The carbocation formed is secondary, benzylic, and allylic. This is well stabilized, but the carbocation is secondary with combined benzylic plus allylic stabilization. 3. The alcohol is on a secondary benzylic carbon in a fully saturated aliphatic ring, tetraline, with no double bond in the aliphatic ring. The carbocation is secondary and only benzylic, no allylic stabilization. This is the least stabilized. Moving on to the next step. I primary carbon but carbocation delocalized over both the double bond, allylic, and aromatic ring, benzylic, simultaneously, effectively an allylic benzylic cation with extended conjugation, making it highly stable despite formal primary nature. To secondary benzylic plus allylic carbocation, well stabilized. 3. Secondary benzylic carbocation, only least stabilized. And for the final step. Rate of dehydration follows carbocation stability, I, 2, 3. Option A, places 3, above 2, but 2 has additional allylic stabilization that 3 lacks. Option C, places 2 first, ignoring that I has the most extended conjugation. Option D, places 2 first and I last, which is incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.